Okay, we'll be verifying that this right here is the general solution to this differential equation. And then for part 2, we'll be solving for the constant c if y of pi is equal to 2. Well, for this right here, we just need the first derivative, so let's go ahead and get to work. We know y is equal to sine x plus c times cosine x. Okay, and then dy dx is of course your first derivative. Well, the derivative of sine x is just cosine x, and the derivative c times cosine. Derivative cosine is negative sine, so we have negative, and c still stays, and we get a sine x right here. Well, now we'll just have to put these two right here and check if they will satisfy or not. So here we go, part A, we check. Well, dy dx is that, so I'll write down cosine x minus c times sine x for the dy dx. And then we add it with parentheses tangent x. And you need to put on these parentheses, otherwise it looks like tangent of x, y. It looks like x and y are both inside. That's no good. So put on these parentheses. Y is this. So we multiply by sine x plus c cosine x, like that. And then in the end, of course, we are trying to see if this is going to give us secant x or not. Well, first of all, right here we know tangent x is equal to sine x over cosine x. So we'll just be distributing that and see what will happen after that. Here we have cosine x minus c sine x. When you take this times sine x, of course you end up with sine squared on the top, so we'll just put down plus sine squared x over cosine x, like that. And then when you take this times that, the cosine cancel, and we end up with c, and that's positive, times sine x, like this. And we are still trying to see if this is going to give us secant x or not. Interesting. Let's see. Well, this and that can be cancelled, and here we have cosine x plus sine squared over cosine x. Is that really equal to secant? Let's see. This right here, let's go ahead and get a common denominator. So right here, I can just put this down as cosine over cosine. Of course, I have to multiply by another cosine here, multiply cosine x, top and bottom. And then of course here we get cosine square x on the top. And then I can put this together with the sine square x on the top over the same denominator, which is just cosine x. Of course, on the top, this right here is just equal to 1, right? Very nice. This right here is nicely equal to 1. And in the end, we get 1 over cosine x. Of course, right here, I think we have shown enough work. This is equal to secant x. So that's done. Now, for part B, we're going to solve for c when y of pi is equal to 2. So let me just put it down right here. We know y is this. Y of pi, let me write it down. Y of pi just means that when x is equal to pi, the result for y is equal to 2. So this right here is y being 2. Well, I just had to put pi into here, and that's pretty much the idea. So I will say this is equal to sine of pi, and then we add this with c times cosine of pi, like this. That should be equal to 2. Now, this is just 2. Sine of pi is 0, so this is gone. And then cosine of pi, don't forget your trick, this is negative 1. So all in all, you get negative c right here. 2 is equal to negative c. That means c is equal to negative 2, right? And you are done. But in the end, I will present the answer for you guys in the following way. We know the solution to this differential equation with this condition, it will be this with c being negative 2. So I'll just put down y equals sine x minus 2 times cosine x, like this. And you can just put on y, or you can put on y of x, one way or the other, up to you, right? I think I didn't write it down nicely enough. Y of x may be better, I don't know. All right, so this right here is it.